Welcome back. Today's test, the cells are the same size as the 16 carbon tests. This is the first test of my first attempt at trying to make Fullerenes. They're a C60 carbon. The other name is buckyballs. I'm not sure if I have it, but the resistance on it isn't too bad. This is what it looks like. It's a real crystalline formation. The resistance on it is not too bad. If I can get this meter. Okay, that meter does an auto scale. And it's saying it's 2.9. I spread the probes apart. And 3.8 in that form. With Kevin Walcroft's idea of carbon measurement device, not a bad idea, Kev. Thank you. You put your carbon inside the two things and attach your probes to the end and screw it in tightly, and you can get a measuring. It's empty at the moment, but that carbon was, I think, was 2.1 or 2.2. It's a sugar carbon I'm trying, and I also have a bread carbon with the same process to make the buckyballs. Yeah, I have the sugar one connected, no electrolyte at the moment. We're going to use Epsom salts as we did in the 16 carbon cell test, because this is another carbon test to compare the energy densities of carbons. I have the meter already set up. It's doing 0.03 volts with a dry cell, and I don't think we'll get a... Oh, I'll put it on the Milli Amps. And short circuit without any electrolyte. Nope. Alright, nothing in there, so I'll put it back on the 200. I'll add some electrolyte. Okay. Alright, voltage went up alright. We're at 0.7 volts on the 20 range. Dropping. Short circuiting. 12. Holding 12 milliamps, so it's looking alright actually. All the other ones started dropping when you short circuited them. Oh yeah, it did drop. It's going down now. Alright, I'll have the charger set on, well, depending on how many milliamps that's going to flow through the circuit, I'll adjust, but we're on, I suppose the other tests were set at 4 volts, so we'll turn it up to 4 volts. Okay, we're somewhere up at 4 volts, and we'll give it a minute's charge. Okay, connecting charger, setting time, we'll wait for a minute. Well, 86 milliamps. No bubbling. The the cells just formed today, so it may need soaking in the electrolyte for an hour or two. It's just brand new, but I couldn't wait. The process for making the sugar carbon and the bread carbon was quite complex. I don't even know if I got it right, but the test might show us if it performs better than the other carbons in the other tests. Perhaps I might be on my way. It's the first attempt though. And we're at 50 seconds. Again, for this test we'll give it a short circuit and measure the highest value we get, and then we'll run the motor just for the sake of it. Alright, that's a minute's charge. We'll see what it bounces down back to. Might probably sit at 1 volt maybe. Stop the timer. Okay, alright, we'll give it a short and see what it's got. 19 milliamps, it doesn't, it's hard to say. It's on its first run. We'll connect the motor and see how long that actually runs for. And setting the timer. Oh, we're not going to get long on a minute. Oh, look, it's speeding up, it's getting there. It's holding its voltage. Oh, the voltage actually went up. Oh, you can actually see the motor increasing in speed. Not delivering way much power, but there's some sort of strange characteristics going on. And the cell's only just been formed, and the electrolyte wouldn't be in through the carbons yet. I'll do a couple of tests on this one. This is just the first. We're at 40 seconds for the motor after a short circuit. Epsom salt solution. It's the exact same solution. It's a bit dirty because the stuff comes out, but it's settled. I just suck the bits off the top. So buckyball carbon. The carbon does feel extremely different. It feels sharp on your fingers. I don't quite like touching it actually. And also in the process I got this extremely strange carbon. See how it's stuck to the top of the lid and the bottom of the lid? They're at different polarities with the static electricity. We'll wait for that test because I can move these around and change their polarity and they fall down or jump back up. And that's a great distance for the little carbon just to move up. But that was a byproduct, or is that the product I'm supposed to use? Not sure. But there's not a lot of that. Alright, we got nearly 2 minutes. We got 1 minute and 40 it was. Oh, don't move that light, might get electrocuted. Okay, alright. So that was 1 minute. So we got 1 minute and 40 on this run. So we'll do the same for the other cell, which is the bread. The bread had a slightly greater ohms reading. I mean, smaller. It was 1.5 in Kev Woolcroft's ohms reading device. I'm going to substitute these zinc coated bolts for some brass later. Alright, so voltage bounce back went to 0.6 on that cell. So connecting the other cell. Okay, we're slightly higher on this cell, the bread cell. 0.14 on dry cell. I'll get some more electrolyte. about the same, 0.7 volts. Both substances were treated the same way. I sort of looked it up online how to sort of make fullerenes. Okay, so for a short circuit without being charged on the bread. Oh, what happened? Nothing. Oh, connection failed. Got that done. Alright, short circuiting on an uncharged fresh cell of bread. It's about the same, slightly up. I reckon the other one was 12 and that started at 13. So we'll give it the same charge. So it's taken more milliamps. It was lower resistance than the sugar one. Okay, it's 10 seconds. And the appearance of the bread one carbon is a bit different. It's not as shiny, but it is silver. But its resistance is less. Alright, we're coming up to 56 seconds and 1 minute. Alright, we'll wait for it to bounce back. I'll reset the timer. Okay, doing a short circuit. 40 milliamps, I think it's got a bit more than that one. And we'll run the motor and see if we get longer than 1 minute 40 on a 1 minute charge. Alright, connecting now. Alright, we started off high in the voltage on this one and we're dropping, but I think we're stabilised. Oh, it went back up, but I think we've got 14 milliamps out of this girl. Don't forget the cells are just formed, so the carbon might not have soaked up all the solution yet. I have two more of the same cells. This is the sugar lot and that's the bread lot. I'm going to use the carbon bread on the sugar aluminium carbon and vice versa. Oh, I was going to check the ohms of that later. We're at 49 seconds and we're holding strong actually. The bread one looks good. Bread's actually stabilising, or the power curve looks a bit better. We've hit the 1 minute mark. Oh, I'm going to probably use this carbon in the nickel iron cell. Actually, I might use the carbon in all the cells now. It does take a lot of work. You don't get a real lot. We're at 1 minute 34. We're probably not going to get much longer. The other one lasted about now. So a tiny bit more. Okay, there, 150, so only a fraction more. But it's still holding 10 milliamps. Firmly. Alright, just dropped. Alright, so I'll give it a 2 minute charge and then I'll get back and we'll see how that performs. Okay, back. It's been... oh man, that spark. I'm pulling that plug on that. I got a dodgy light there. Not going to touch that. The camera's attached to the light. Alright, nearly at 3 minutes now on charge. Okay, that was 3 minutes. Nearly got electrocuted live on YouTube. Yeah. Alright, 3 minutes. We could go down more in the milliamps. Well, that's going to be hard now. Alright, disconnecting, resetting the timer. Okay, alright, we won't short it out, we'll just connect the motor and see how long it actually runs for. Connecting now. Alright, we're delivering 27 milliamps and dropping. This is the bread one again. Bread buckyball carbon. Maybe. Well, voltage is up at still 0.4, which is looking good. And 20 milliamps. Can you see the scale? Oh yeah, just. Have to look at my light, why it's sort of arced out then. Okay, we're probably going to get more than, what was it, 1 minute and 50 on this one, because it's only just dropping now. It seems to be a way improvement in the carbon. So to get good carbon, you need a bit of effort put into it. But in the backyard it's possible, look. This is the first run. I have not seen this run, so I'm quite amazed it's holding. I was trying to follow the procedure of making buckyballs, carbon C60 family. You've got to have a good container, and it needs a little pipe with a gauge so it's not in the heat area, so it doesn't get affected, so that might affect the process, but you have to watch your pressures or boom. Look at that, it's 0.3 and holding firm. Normally it would drop. That's just a, what was it, 3 minute charge. I got to remember to do that one as 3 minute too. But we could have took the milliamps down a bit more. It may have even dropped down to 10. Not sure if that actually means anything, but a lot of the other charging videos I'm trying to be watching, sort of their milliamps do drop, and then they get to a point and they sort of stabilize. Alright, we're at 3 minutes. We got a 3 minute charge. We had a 3 minute charge time, and we're at 3 minutes run time, and we're still going on bread Fullerenes. .2. The power curve's pretty good, considering that's a big load for this cell. The cell's only this big, and I think it's way less than a gram. I can't measure it on my scales, only grams, so it's a way small amount of material. Well, I'm actually impressed with this carbon. There's still a lot of other carbons to be made out there, or variations. I'm going to try the cross-mix carbons later. 4 minutes on a 3-minute charge on a brand new cell. And we're still delivering 10 milliamps. Yeah, I think that carbon so far has bet all of the other 16 carbons. The only one what came close to that one was on a short circuit was the activated carbon, but its runtime wasn't as good. Alright, we're getting... Oh, we're stopped. Alright, we're at 4 minutes 42 on that one. And we'll see what voltage bounces back up to. Voltage is a bit low, but I think it might think it's the same carbons because it sort of is. The carbon plate and the aluminium plate have the same carbons at the moment on both cells. So we'll see when we swap each cell. We'll have a sugar carbon on the bread carbon and a bread carbon with the sugar carbon. Alright, 0.67 volts on that one and 4 minutes and 40. Alright, I'll set up the other cell and start a 3-minute charge. Okay, we're coming up to a 3-minute charge on the sugar one, but the Milli Amps is fluctuating now and it's not decreasing. Oh, it just did, but it will jump back up in a minute. Alright, that's 3 minutes on charge. Oh, can you see everything? Alright, disconnecting cell from the charger. Reset the timer. Okay, alright, connecting the motor and let's see if we get 4 minutes and something out of this cell. Alright. The sugar one might be a finer grade and the electrolyte's not through it yet, so the test could still be inconclusive. I'll keep them in their solutions overnight and keep testing. See, we're 0.3 and it's only 30 seconds on the sugar carbon one. The sugar Fullerene. But that one might not have worked. We've still got 13 milliamps. And this one's holding 0.25. Right, there we go, just dropped. It's only 1 minute and 17 seconds. Yeah, so if you get a chance, do a search on Kev Woolcroft and have a look at his carbon powder ohms measuring device. Thanks, Kev. Excellent idea. I found that piece of plastic in the car park 2 weeks ago and I was wondering what was it. I kept it anyway because it's a nice piece of industrial plastic stuff, Teflon or something maybe. Nylon. We're at 2 minutes 18 and we're probably going to run out, so we're not going to get 4 minutes. This little one got 4 minutes, but we'll see how it goes later on after another test in an hour's time for this one. I'll let the electrolyte soak in. It's exactly the same electrolyte out of the same container. I really have to plot a curve for it because it might have different levels where it sits constant for a while longer. We're at 3 minutes. 10 milliamps at 3 minutes on a 3-minute charge. There we go, we're out. 3 minutes we made with the poor little sugar Fullerenes. And we'll see what this one bounces back to. Oh yeah, sort of, it's going to be at 0.7. It'd be interesting when we alternate the carbons to see if the voltage goes up. If it does, it recognises the aluminium and the carbon in this one as the same type of cell, because it is the same carbons coated on each. Alright, well, thanks for watching.